All right, so parameters and a little bit about Yagis, parabolic reflectors, circular polarization, loading coils. Well, that's the fun part. That's got the question that I really have trouble with. Or no, the feed point impedance of electrically short antennas is the nasty question. Top loading, antenna Q, and grounding. So when you do a Yagi, forward gain isn't necessarily the most important parameter because you got to worry about the front to back ratio and front to side ratio. So as you play with the spacing of the elements and the length of the directors, it changes all that. So you kind of have to optimize it as whether you just want front to back gain or you want narrowest bandwidth or one of those parameters. So what usually occurs if a Yagi is designed solely for maximum forward gain? Very good. Everything's a trade-off.
Well, that decreases the need to pick up more inherent noise and QRM. Right. We're trying to be directional. So
and maybe long path. Type around. Yeah. Okay. Yagis and parabolic antennas. If you operate a Yagi or a parabolic as horizontal polarization, you can do weak signal work on the VHF and UHF bands, they tell me. I haven't tried it, but I might soon because somebody offered me a Yagi for 2 meters.
All right. I got one yesterday.
Oh, you did?
A little 4-element.
Okay.
It goes for like 180 and I got it for thirds.
And I was told that you can make contacts around here on VHF, UHF sideband, horizontal polarized.
Yeah, I think Monday night net, if I remember correctly. That's a 2-meter sideband net.
What kind of distances you talking about?
You're talking 200 to 300 miles.
Really?
Yeah.
Okay.
I do all my 6-meter on horizontally polarized.
Okay.
The dipole. Yeah.
Normally use vertical if you're doing FM with repeaters or simplex because the repeaters are normally vertical antennas and you're using a handheld or a mobile, which is normally a vertical.
But the sideband guys will do, they'll get, they called, I guess, a squalo, which is a half-wave dipole that's folded into almost a loop.
Well, it's almost a loop.
It's not closed.
At the feed point or the opposite end?
At the opposite of the feed.
Okay.
It's not quite. If you look up squalo,
okay.
Square.
Yeah, I've seen one like that.
Yeah. And they'll stack 2 or 3 of them to get some pretty decent gain, you know, in an omnidirectional pattern. That way they don't have to swing around. They can talk to everyone in the net without swinging their Yagi around.
Okay. In a lot of cases, you'll use cross polarization or circular or elliptical. If you're trying to connect with a satellite, they're normally circularly polarized and they're rotating. So even if they weren't, they turn out to be circularly polarized or effectively. You can do it with 2 Yagis or other kind of beam antennas where you mount them perpendicular to one another and have the driven element at the same point on the beam. But you got to feed the two of them out of phase. And in case of circular polarization, the horizontal and vertical components are going to be 90 degrees out of phase anyway. So that allows you to pick up the whole waveform. Of course, the disadvantage is you got to have two antennas and a little phasing wire. So how can linearly polarized Yagi antennas be used to produce circular polarization?
Stack 9 degrees out of phase. That sounds like my work.
Charlie.
Perpendicular.
Yep.
Perpendicular.
If you stack them, you can get 3 dB gain.
Yeah. Well, the perpendicular gets a circle.
Right.
And 9 degrees out of phase.
All right, parabolic. I know nothing about parabolic except that's what my old DirecTV used to use. They tend to use it more at microwave frequencies, and you see them on these microwave towers. Basically to act as a beam antenna and direct the signal. The bigger the dish, the higher the gain for a given frequency. And as you go up in frequency, you get more gain with the same size dish because it's effectively larger for the wavelength. And they're saying 6 dB when you double the frequency.
See a lot of these on the overseas highway heading out of Key West. I guess it's a lot cheaper than running wire that far.
Oh, I'm sure. And it's a narrower beam width. The higher the frequency for the same size antenna. How much does the gain of an ideal parabolic dish antenna change when the operating frequency is doubled?
Delta.
Yeah. Because if you didn't pay attention, you'd pick 3 dB.
I didn't.
Antenna efficiency, shortened and mobile antennas. Okay. So, because most mobile antennas are shorter than they should be, and they use a loading coil at the base or the middle or a couple places. They're normally operated below the resonant frequency. The radiation resistance decreases and the capacitive reactance increases when you're operating it below its resonant frequency. Now, that's the key one that's on the test question. And I had trouble remembering that one. In most cases, you've got a loading coil somewhere on the antenna to give you a 50 ohm match. It helps cancel out some of the capacitive reactance because of the fact that it's a shortened antenna, so you're operating below its resonant point. And the coil is just there to make it appear electrically longer than it physically is. So what happens to feed point impedance at the base of a fixed length HF mobile when operated below its resonant frequency? It's kind of a weird one because they want to know the feed point impedance, but then the answers are all radiation resistance and reactance.
I'm going to say Baker.
So Charlie. Radiation is going to increase. Oh.
Yep, that's the correct one. But in 3 or 4 weeks, will you remember that one?
Yeah.
What is the function of a loading coil used as part of the HF mobile antenna?
And
D.
Yeah. Delta. Okay, efficiency. They're inherently inefficient because they have a lower radiation resistance, and radiation resistance determines how much radiated power you're actually going to get out of the antenna. And when you put the loading coil in there, you're going to add additional ohmic resistance, which is going to affect the efficiency. If you put the coil in the middle, okay, you can, I guess, increase relatively the radiation resistance. It's still going to be lower than if it was a full length resonant antenna. But I think what happens is you also increase the capacitive reactance or the inductive reactance that you see at the feed point, which is going to require you to offset that. And that's where I think the next one on capacitance hat's coming in, which is another one that confuses me. So why should an HF mobile antenna loading coil have a high ratio of reactance to resistance? What are we saying?
Minimize losses.
Charlie. Yeah.
Minimize losses. Where should a high Q loading coil be placed to minimize losses?
Alpha.
Yeah, you see the 11-meter guys take that serious.
Yeah,
Well, the problem with the loading coil standard like that is the weight of the coil
right.
to your stability.
That's one of the trade-offs.
So that's why you still see them
At 60 miles an hour, how does
at
it
the
affect
base.
it?
They just keep the base, so we don't.
That comes up with capacitance hats too.
Well,
Because the optimum one is more wind resistance.
Exactly.
well, that's also why they have a pickup, to get that big loading coil behind the cab.
Yeah.
So,
Yeah.
yeah.
Okay, so if you have a loading coil, it's going to decrease your SWR bandwidth. It's make a narrower band. Which means if you move around on the bands, you got to retune it or rematch it because you can't really tune it unless you got the step IR. Is that is that the one that, or the screwdriver? Excuse me.
Screwdriver.
Yeah.
Yeah.
That tunes it, right?
Yeah. Just your loading coil. That's bottom loaded.
Yeah. Which is not optimum.
That's even for band changes too, right? Depending on the width.
So as the Q of the antenna increases, the bandwidth decreases, which makes sense. Just like the Q of any resonant circuit, the higher the Q, the narrower the bandwidth. So what happens to the SWR bandwidth when one or more loading coils are used to resonate an electrically short antenna?
Baker.
Sounds good.
So it's interesting on if you had a full size vertical, quarter wave vertical antenna, 20 meters, and what the bandwidth would be versus a loading coil. Because I've got like Wolf-Rayet coil antennas, 102-inch width, 20 meters loading coil, you adjust it to wherever. But I can cover the entire 20-meter band with a Wolf-Rayet coil
At one setting.
at one setting. So it's not.
So you're two to one at that. Two
Yeah.
to one 11.
Yeah. So, but I wonder what would be. I don't have a full vertical without a loading coil, but what would a quarter wave 20-meter verticals
Well,
2 to
your
1
your
band.
SWR would change less
Yeah.
over the band.
Yeah, that'd be true.
Now,
That's get better opportunity, yeah, better SWR on these bands.
with the, isn't, it seems like there'd be a detrimental effect for a loading coil because
Well, there is.
physically won't have that length of wire,
Right.
length of antenna to receive a signal. So it seems like you would be affecting your reception quite a bit by having a coil.
Well, it's got to add some ohmic resistance, so your efficiency goes down. And it decreases the radiation resistance relative to the full size. By moving the coil up, you get some of it back, but it's not as good as it was full length antenna. And that moves the current. The problem with the bottom coil, as I understand it, the maximum current is at the bottom of the antenna and 0 at the top. So your most of your radiation comes from the highest current point,
Which is the bottom.
which is the bottom, which is not as good as the top. Although when you're only talking to 5 feet, I don't know how much difference it makes.
Tell your conscreen I'm interested, John.
It does make a difference on a tall vertical with its bottom loaded or.
Like these scans, that'd be my time.
So what happens is the Q of an antenna increases. All right.
Baker.
All righty. Top loading or capacity hats. It turns out from little research I did, the one on the right, the wheel is the optimum shape as far as efficiency for a capacitive hat. However, it's the worst shape for wind loading.
Yeah.
And it turns out, and the one in the middle is one of the least efficient ones as a capacitive hat. So the one on the left with the 3 loops turns out to be the optimum for practice. It has the best capacitance effect with the least amount of wind resistance.
There's a guy that did very, very well, 80-meter mobile. You know, you have the QSO contest for the state. And this guy cleaned up with a setup like that, in the middle group of his car. Little screwdriver antenna with a capacitive hat. But he absolutely killed it.
And from what I understand, as you like raise the loading coil up towards the middle, you increase the inductive reactance. So you need the capacitive hat to offset with more capacitance to offset the extra inductive reactance. I'm still confused about those things.
Yeah, how does that contribute to capacity?
That's a good question. All I know is that they're capacitive.
It's magic.
And because it's a right angle to the radiator, they're not radiating.
I think. Does that have something to do with it? It's at a
Right angle, yeah.
90-degree
Yeah.
to the.
At least it's not radiating in the same plane. And it's magic.
There you go.
I don't think that's what they want us to.
It's not one of the answers.
Well, all right. So what's an advantage of using top loading in a shortened HF vertical?
I would have said Delta, but
Well, you would have been right. It improves the efficiency. It doesn't make it as good as a full-size antenna.
right.
And it's if you do a little research, you'll find all this stuff on how it offsets the extra inductive reactance and stuff, and gets confusing because, well, I won't go into it now.
Well,
It seemed counterintuitive to me when I first started looking at them.
but remember, you're adding a loading coil for a shortened, physically shortened vertical. So you're
Right.
adding inductance to get it electrically.
Yeah, but
So-
remember a while back, it said when we did that, operating it below its resonant frequency, it was capacitive.
Right.
So why would we be adding more capacitance? That's the part that
Yeah.
got me. I still don't totally understand this.
It's magic.
Okay, but wait, so you add inductance initially, yeah, because you have to add the loading coil.
Right.
And because without the loading coil, you got more capacitance, so.
Right.
About your peak.
So the loading coil is offsetting the capacitance with more inductance, right?
Right.
Okay.
So
And
that-
it overcompensates, so we gotta add more capacitance on the top.
So that they can be resonant, is the reason we have the loading coil, because the electric short antenna becomes capacitive. So now you can get the antenna resonant, this is the point, remember resonant is inductive reactance capacitive, right? Null out.
I have it figured out there in the ideal realm.
Yeah.
Let's see, was that Plato or Aristotle?
Okay.
There's a big reservoir of capacitance. And to get in tune with that capacitance, you have to have the correct orientation. And the vertical is not, orientated to the ideal. But you have both the vertical and the horizontal.
Yeah.
When you have the vertical and the horizontal, with the horizontal on top, it's in tune with the ideal. And that's where the capacitance comes from. I just got that.
Okay.
I figured it was just.
All right.
Confucius
It's
that-
magic.
So what they said about the benefit is includes the radiation. Or the radiation.
Yeah.
That they just said.
And I read that the other day
You have a better answer?
on why it did it.
All these engineers, and we don't have a better answer than my
I
answer?
can't pinpoint it, but it comes down to something to do about the.
Well, without the capacitive hat on it, or the capacitance up there, you're gonna have some reactance. So the reactance figures in to the total impedance. And remember,
Yeah.
the impedance is radiation resistance plus resistance losses.
That's what we're going.
So if you've got extra impedance in there, it takes away from the
Okay, so typically if it's pure resistance, it is what it is. Now it's loading coil to offset the capacitance and capacity. Somehow
right.
the reactance component gets larger. So now you got your core resistance in the net reactance, which is a larger chunk of the total resistance. Therefore, your antenna efficiency becomes a small percent. So
But you can do some magic with the conjugate sort of matching of the impedances and actually change the effective ohmic or real resistance. Which is more magic.
So,
you can change the
conjugal
size of
match,
your
is that like
capacitance.
conjugal
Yes,
visitation?
that's exactly what it is.
Now,
Okay,
I got a vertical yesterday for 10 meters.
yeah,
It's a quarter wave, and it's got a capacitive hat type element in the middle of the thing.
does it have any loading?
okay.
Anything?
No,
No close.
Well, I've seen some of those verticals that have all kinds of things, little loops and other stuff hanging out all along, and I don't know.
maybe it's just a marketing strategy.
Well, I don't know.
It's probably some sort of broadbanding. For
It
10
costs them money to put it
So,
there, so
10
it must be
meters
doing
It's
something.
hard to have an antenna that will be blocked.
Okay, RF grounding. You can't use the power company's safety ground as your ground. One reason, it's normally only a very small gauge wire coming from your service entrance down to a ground rod. which may not be a very good ground rod. In my case, it's been there 50 years. I'm not sure how much ground rod there is.
Florida, how much safety ground do you need?
So what the intent is that you need to have the least amount of impedance to ground from your station equipment. Wherever your single point ground is, that all your transmitter and everything is tied to, as well as the shields on the coaxes when they come in, should all go to that single point ground, and then out to at least one ground rod connected with preferably flat copper strap or very heavy gauge wire for the surface area. And that should be connected to your safety ground. Now, if it's a distance away, they kind of recommend that you run a heavy gauge wire from your ground rod to the service entrance ground rod and have a ground rod every 8 or 10 feet along the way. And ideally, you would want to run it entirely around your house, shack, whatever. And in the real commercial world, like broadcast stuff, they do that, as well as all the stuff on the roof and ground lines going up the corners and the whole 9 yards. But that gets excessive.
Disconnect everything when you're not operating.
Well, but when you're operating, it makes a difference on your ground. Because if you have a very high impedance to your ground, you don't really have a ground for RF.
I never run a ground when I'm QRP. Well, I do sometimes.
Well, okay. But yeah, you're a different case.
Yeah.
Not only when you're QRP. Okay.
Mobile
Huh?
operation, you got a ground rod on your car?
True. I could drag a ground strap, I guess, on the road. I've seen that.
Download the app.
Which of the following conductors would be best for minimizing losses in a station's RF ground system?
Bravo.
Okay, this is kind of showing one of the approaches. I know this is what they do at P-cars in their shack.
Yeah.
With copper pipe on the walls as their single point ground and tying everything to it, and then running it out to, well, I haven't seen their ground system. You probably have, probably more than one ground rod out there, right?
Yeah, I think they got a bunch of. I haven't ever seen the ground rod.
Maybe it's in the ground.
Maybe I need to look at it.
Yeah. All right.
So actually, I got a question here.
All right.
We live in Florida.
Yeah.
Behind my house, there's a drainage canal, and there's always water in the drainage canal. That leads me to
Right.
believe that the water table is probably not very far below my house.
Probably not.
Okay, so and everything that I read says that you need to have an 8 grounding rod.
That's kind of standard length,
Right.
8 or 10 feet.
Well, I've got 2 4-foot grounding rods left over from when I used to do satellite system installations.
You're fine.
It's better than none,
Well,
and 2 of them better than 1.
Well, I'm probably gonna put one behind the house when I get around to setting up the shack, and then the other one will be part of my go kit for when I go do POTA at parks. Provided you're allowed to put stuff in the ground.
Okay.
You'll be better than nothing, but the more ground rod you have in there,
Right.
the better you are. And if it's lightning protection,
Mhm. I do exactly what you just said. When I shut it down, when I turn it off, everything gets unplugged. Power, antenna, everything.
yeah.
Now, it's possible in Florida, I guess other places, you could have an offer ground. an Ophir ground,
What's that?
where when they do the slab,
Mhm.
because most houses here are built on a slab,
Right.
they put wire mesh in it and bring out a connection to it. And that is supposedly a great ground, better than a ground rod.
Right. Okay.
Of course, I don't know if you've got one of those somewhere or a way to connect to it.
Yeah.
Some guy named Ophir, I guess, invented that.
Seems like a great ground would be to like your well or your, you know.
Yeah.
If we have a
You,
well.
you have
yeah.
a
If it's
steel
metal,
sleeve,
yeah,
Yeah.
a lot of them are PVC.
steel
PVC now.
Yeah. That's the problem with water pipes you can't use anymore because you're probably not connected metal to anything, especially in a newer house. You probably don't even have metal.
Michael has a question.
Michael has a question.
His hand is.
Michael.
I have two questions.
Uh-oh.
One of them is here, and what you just talked about, the offer thing.
Yeah.
So a lot of times in the pads that they pour, they put um, a big square, like a 4-inch square mesh in it, to hold that cement and everything together
Right.
better. Would that be something you could use, or are you really looking for like, copper cloth or something to put in there?
No, I mean that's what they do with the Ophir, except they bring some connection out.
Right,
And
right,
I mean it's standard building code to have the wire mesh.
right. Okay.
But
So my second question is, if you'll go back 2 slides.
okay. That
Okay,
one?
so here we talk about a flat wide copper strap is the best conductor because it's got more surface area. And
Right.
then it talks about copper strap has many conductors braided together to maximize surface area. So is there more surface area in a copper strap that's like you pull the braid off of a great big cable, and flatten it out? Or is it just as good if you have like a 2-inch wide actual flat copper strap?
Okay. A braided copper strap, and they're usually tinned so they don't corrode,
Right.
is better, but you kind of have to use it indoors. If you're
Okay.
going outside, then you want regular flat copper strap, not
Gotcha.
braided.
Okay.
But you don't use the braid off of coax.
I know. I'm just saying I was trying to use that as an example of what I was thinking of.
Okay. But that's an example of stuff you shouldn't do is try to use, take some old coax and, pull the braid off of it and use that
No, no.
because it's not, for one thing, it won't be tinned and it's
Right.
very fine wire and it doesn't work well. And outside, it doesn't work at all. No longer.
Gotcha.
Is why if you get a water leak in the jacket of your coax, it kind of wrecks it.
Right.
It
And the
corrodes
copper
very
strap would
quickly.
be more flexible.
Yes, that's what I
Yep.
use to connect my equipment to my ground plate where my
Yep.
entrance panel is. But I got
Gotcha.
a 2-inch wide copper strap on the outside going down to a ground rod.
Okay.
And it was an expensive piece of copper strap too.
Yeah. Thank you.
Okay. Okay, so which of the following would provide the best RF ground?
Charlie.
Ground rods, see,
Yeah.
yeah. Shortest connection. Ground rods.
The more ground rods, the better the lower your parallel resistances.
Right. And the ground rods have to be bonded, right?
Yes,
Connected.
yes.
Yeah.
everything's supposed to be tied together. Like if you got a tower, then you're supposed to have a ground rod at each corner. Usually they're triangular, so you'd have three, and then all tied together and then tied into your ground system.
Are they getting one use copper strap to tie them all together too? Or can you get away with?
Well,
a heavy
you
gauge
could, but
burial?
normally I don't think they do. It's just heavy, 6 gauge, 4 gauge wire.
6 gauge,
Clamp it
4 gauge, you're a wimp.
I know, I'm cheap.
I'm gonna tell KU0R on you.
It still cost me $75 for a 100-foot roll of 6 gauge wire.
Well, if you're KU0R, you want like quadruple aught stuff. Big as your thumb,
But that's
That don't work railroad track well, right?
as long as it's pure copper. So we called Dave.
but that's
Hooper Dave.
multi-conductor,
Well,
which means you got to keep it sheathed, otherwise it corrodes in between. Not good. You want solid wire.
so you can't get a shielded one?
With insulation, yeah, but that's kind of,
That's more money, right?
and it's diminishing returns. How much better is it?
Not for nuclear, Dave. It is not diminishing returns.
Okay. I'll stick with my 6 gauge.
Okay.
I was too cheap to go with 4 gauge. And it starts to get hard to bend.
Yeah.
6 gauge, solid conductor or?
Yeah.
Solid,
You can get it at Lowe's,
right.
not Home Depot, unless they special order.